Okay, you should have completed numbers 1 through 3 on this task because we're looking at these cell phone signals with the various bars. So on that first one, if you have done it correct, you should have got a figure that looks like this down here, right? Has 5 on the bottom and 5 going up, and it's almost like stairs going up to it. And that has a total, so that was for the next figure, so this is figure 5. And then you had to somehow recognize the pattern to get to figure 10. So if you did that correctly, you should have got 55. I did a little table over here on the right with the figure and the number of blocks. So I noticed it added 2 and then 3 and then 4, 5, 6, etc. And I kept adding it up till we got to 10. Figure 10, which had 55. If you're having some hard time seeing it, I'll show you 2 ways you could have looked at it. You could have looked at like it adding the stairs, so that added 2. This one added 3 stairs. This one added 4 stairs. Or another way to see this visually is to say, okay, well, this one had 1 figure and we added this ending column which had 2. This had 2. To get to figure 3, we added another column which had 3. Figure 3 had 3, we added another column, we got 4. Either way you look at the picture, you will still see that we're adding those numbers there. We should have got to 55. Okay, so those first 2 I think were pretty kind of straightforward going. So now we want to examine the sequence and find a rule or formula for the number of tiles in it. So here you may notice, if you just wanted to put it in like words, that we're adding the figure number to the previous term. So for example, to get to figure 2, we're adding 2 to what figure 1 had, which is 1 term. To get figure 3, we're adding 3, which plus the 3 that figure 2 had. To get to figure 4, we're adding 4 plus how many ever blocks figure 3 had. So that's one way to think about it just in words. If we wanted to think about a formula, I think here a recursive formula would be pretty easy. So remember our recursive formulas? We start with f of 1, so how many did our first term have? In this case it had 1. And then we use f of x, or you could use f of n. I'm going to use f of x because that's how your homework does it. And then we have that funny thing like f of x minus 1, which means the previous term. So remember, to get to figure 2, we take figure 1 and the blocks in figure 1, and then we add something. To get to figure 3, we take the blocks in figure 2. That's what this f of x minus 1 means. It's that previous term. And in this case, since we're just adding the term number, we're going to just say that's an x, right? So for figure 2, we're adding 2. For figure 3, we're adding 3. And there's one last way we could look at it. So as we look at these, we could think about it almost like a triangle. So as we think about the triangle, you could see, notice here, we got an extra one, but I've got some extra blocks on the side here, right? So you could think about that area of the triangle. So this part down here, remember the area of a triangle is just 1/2 base times height. So in this case, the area of the triangle, think of 1/2 base times height. 1/2, your base is just 1, 2, 3, 4, or if it's 3 for figure 3 or 2 for figure 2, is just x, and the height is also that x. Okay, but there's a little bit extra, right? So that little bit extra here, if we look at figure 4 as an example, we have 1, 2, 3, 4 little triangles. So that would make 2 blocks, right? Or we look at figure 3, we have 1, 2, 3 little triangles. So that would make 3 half blocks, right? Figure 2, we have 2 of those triangles that if we put together and make 1 block. So we have another half of whatever that x is. So another formula we could say, in this case the explicit one, is f of x equals 1/2 x squared plus 1/2 x. That is not the only way to look at it. Some of you may have done something that looks more like this. I'm not going to show you this image, but if you did something like 1/2 x times x plus 1, that's also correct. For the time being, I wouldn't worry about this right now. We'll get to that, right? This is a new kind of equation that we haven't seen in secondary 1. So I wouldn't stress right now if you don't understand that, but I would say, okay, for your homework tonight, we got to recall what we remembered from last year. So let's look back at what we remember about linear and exponential. So if you want to take a moment and pause the video and just kind of write down some of your own thoughts, then I'll go ahead and tell you some things that you should remember. So linear, another word for that is arithmetic, right? Whereas exponential is geometric. Remember, linear is like add and subtract, whereas exponential you can think of as a multiply / divide. If you think about the graph, this is a straight line, right? Whereas this is a curve, right? Usually it looks like this or like that. Could be discrete, those are just the continuous graphs. You have things, linear is always going to have a common difference, whereas exponential has that common ratio. Something that they both share is they both have some starting point, right? They both only go one direction, so they both either increase or decrease. Right, they don't do both. And maybe you have some other thoughts that I don't have there, but those are the types of things that you should know at this stage, right? As we're thinking about this unit, because we're going to learn something new, right? What we just did above here, this is neither exponential nor linear. Okay, so that's going to become important. I'll give you one kind of thing to look for as you think about this one. So you may notice, hey, like we're starting to get like, we're adding a linear here, right? We added an x. Something kind of cool if you look over the table, what's the difference between 2 and 3? There's another 1, right? What's the difference between 3 and 4? Another 1. Sorry about that. 4 and 5, there's another 1. 5 and 6, there's another 1. 6 and 7, there's another 1. Notice here what we call the second difference is going to be constant in this case. So that will become a key idea. But for right now, we can just say, hey, this thing that we're seeing is neither exponential nor linear. And we're going to spend a lot of time learning more about that. Because remember, this is just a developing understanding test. So we don't know everything yet. With that being said, as you look at your homework tonight, we're going to want to remember some different formulas, right? So last year you learned about linear arithmetic or exponential and geometric formulas. I put the explicit ones there to remind you. And just as a kind of like helpful hint, I said, okay, let me just give you these formulas, right? So remember f of 1, which we see a few times here, is just the first term. And it doesn't matter if we're talking about linear or exponential, right? You see it in both of them. It is always going to be the first term. Whereas f of x, which we see in both, is the xth term, right? That's the term we're looking for. The thing that differs about these two equations is the d is the common difference. So remember, if you're like have a difference of 2, it's going to be positive 2, whereas if you're subtracting 2, we just call it a negative 2. and your r is your common ratio. So if we're multiplying by 2, it'll be a positive 2. And in this case, if you're dividing by 2, remember you use that ratio of like half. The one thing I want to remind you, which we put in our notes before, but remember this f of x minus 1 is just the previous term. So recursive ones, remember you always have to know what comes before. But for those of you who kind of like formulas to plug things into, you got those to help you out. Okay, we're now going to put these equations to practice. So notice it says in each set of 3 functions, one will be linear, one will be exponential, and one will be a new category, right? That's what we were seeing in the task. List the characteristics that helped you identify it as linear and exponential, and what are some characteristics of the new function. Find the explicit and recursive. So here we are timesing by 5 each time. I think this is one that you'd probably would recognize because you'll see like 1, 5, 25. You see 1/5, 1/25. So here we know that that's going to be exponential. And I'd say that's simply because it's times by 5, it's multiplying. So we look at our explicit equation. We got f of x equals, our first term, just be careful, our first term is down here, which is 5, times your 5 times x minus 1. Which, in case you're curious, yes, this is equal to just 5 to the x. Your recursive is going to be your first term, which is equal to 1, so f of 1 equals 1. And then f of x equals f of x minus 1, meaning the previous terms, times 5. Okay, let's look at this next one. What's happening here? Doesn't look like it's multiplying this time, but we are just adding 2 each time. So therefore, it is linear, you could say, because we're just adding 2. So now, let's think about the explicit equation. F of x equals, hey, we need the first term. So here you're going to have to work backwards. Like, the 5th term is 9. Keep subtracting 2. The 4th term is 7. The 3rd term is 5. The 2nd term is 3. So the first term is 1. So now that we got the first one, f of 1 is 1 plus your difference is 2 times x minus 1. Or for someone who wanted to know what that is equivalent to, you could say that's just 2x minus 1. Your recursive will do similarly. F of 1 equals 1. And f of x equals f of x minus 1, meaning the previous term, but we're adding 2 each time. Just from that, since we know those are exponential and linear, this is going to be that new function. So let's see how we may be able to recognize it. You'll notice here we're adding 13, then we're adding 15, we're adding 17, and 19. Maybe like, oh, well, hey, we're adding odd numbers. I would just say more generally we're adding different amounts, right? And the thing I want you to start recognizing is do that second difference, right? If I look at here, we're adding 2 each time. That's going to be a key characteristic, right? This second difference here, what we just found. That common second difference. So I'm going to put it here as well. The common second difference. Okay. I'm not worried. If you do not write the explicit equation right now, that's just great. Like, you do not have to stress for that. Those people who want the challenge, it is f of x equals x squared. See if you can figure out why that is. But our f of 1, you would have to go back a bit. Or, if you want like a little trick to make life easier, you could actually start a recursive equation at the 6th term. So do f of 6 equals 36. And that's the same with what we did in part B. You could have done f of 6 was equal to 11 rather than f of 1 equals 1. But here it may just be easier to start at the 6th term. And then we can do f of x equals the previous term. And now let's see if we can figure out a way to represent what you're adding. So here, when we go to the 7th term, we're adding 13. When we go to the 8th term, we're adding 15. When we go to the 9th term, we're adding 17. So let's think about it. You want to somehow associate like this 7 with 13, and this 8 with 15, this 9 with 17. You may start to recognize there, hey, if I double 17, I get 14. If I double 8, I get 16. So by doubling, do 2 times x, we get 1 more than what we want, so we're also going to subtract a 1 there. this is what I do expect you to start to recognize some of those recursive patterns. Figure out that relationship. Always draw a picture if it helps. Okay, the last two examples here are just to make sure that you're ready for the go and the ready on your homework. So these are things that are kind of review or help prep us for things we're learning in the future. So rate of change, identify the rate of change. That's another way to say slope. So remember that, it's like the rise over the run. The change in y over the change in x. If you give it a graph, I find the easiest way to do that is just find 2 points that are like where the crisscross are and then count. So we're going down 1, 2, 3. So we're going down 3 and over 1. So that means the slope here is negative 3 over 1. So we'd say here just negative 3. With 2 points, there is an equation, but I have found that students really like just thinking about a table, x's and y's. So negative 3, 2, and 4 and negative 7. There's more than one way to do this. But if we're thinking about the change in y, how do you get from 2 to negative 7? We're subtracting 9. Then make sure we do the same thing with our x's. To get from negative 3 to 4, we're adding 7. So the change in y is negative 7 over the change in x, right? Your run is negative 9 over 7. So negative 9 sevenths there. The last thing it tells us for the ready parts, that's going to be the beginning part of your homework, to simplify. So when you simplify, we're just basically thinking about this term out front and we're multiplying it. So remember, we distribute. So 5a times 2a, that's a little tricky. 5 times 2, right, is 10, but then we have a times a. When you have two a's together, that becomes a squared. And then we're going to do minus 5a times 3. So there you just do the 5 times 3 and you get minus 15a. So on the ready part of your homework, the beginning part, you're just going to distribute. All right, good luck with the assignment.